AI models are getting scary smart. They can write code, explain databases, debug errors, even reason through complex systems. But ask them something practical, like, why did checkout failures spike after the last deployment? And suddenly, they struggle. Not because the model is dumb, because it has no context. To answer that question, the AI needs two things. It needs to understand your system, and it needs access to your tools. For example, what does checkout failure even mean? Is it a payment decline? A backend timeout? A failed order creation? A Stripe error? Which service owns checkout? Where are the logs? Which dashboard matters? And which deployment happened before the spike? That is the knowledge problem. But even if the AI knows all of this, it still needs access. It needs to check logs, read deployment history, look at GitHub commits, query the database, and inspect monitoring dashboards. That is the access problem. So the real problem is not intelligence, it is context. This is where OKF and MCP come in. Think of it like this. OKF is the AI's memory. MCP is the AI's hands. OKF tells the AI what things mean. MCP lets the AI actually do things. OKF stands for Open Knowledge Format. It is a way to store company knowledge in simple markdown files. One file can explain a database table. Another can explain a metric. Another can explain a service. Another can explain a runbook. So instead of your system knowledge being scattered across docs, wikis, code comments, dashboards, and senior engineers' brains, you turn it into structured knowledge the AI can read. For example, an OKF file can say, this is what checkout failure means. These services are involved. These logs are the source of truth. This dashboard shows the failure rate. And this is the runbook. And because these are just files, they can live in Git, so teams can review them, update them, and version company knowledge like code. Now, MCP. MCP stands for Model Context Protocol. People call it USB-C for AI, because before MCP, every AI app needed custom integrations. One for GitHub, one for Slack, one for Postgres, one for Stripe, one for every internal tool. That gets messy very fast. MCP gives all of this a common standard. An MCP server can expose tools, resources, and prompts to an AI agent. Tools are actions the AI can perform, like running a query, checking logs, creating a ticket, or calling an API. Resources are things the AI can read, like files, database rows, documents, dashboards, or logs. So MCP gives AI a standard way to connect with real systems. Now combine both. You ask, why did checkout failures spike after the last deployment? First, the AI checks OKF. Now it understands what checkout failure means, which services matter, where the logs are, and what the runbook says. Then it uses MCP. It checks deployment history, reads the logs, looks at recent commits, queries the database, and compares the failure spike with the latest release. Now it can answer with something useful, like, the spike started 4 minutes after the payment service deployment. Most errors are Stripe timeout errors. The likely cause is the commit that changed retry logic. That is the difference. Without OKF, the AI may check the wrong thing. Without MCP, the AI may know the right thing, but cannot access anything live. OKF gives meaning. MCP gives action. OKF is the slow layer. Definitions, schemas, services, metrics, runbooks. MCP is the live layer. Databases, APIs, logs, dashboards, GitHub, Slack, tickets. Together, they form the AI context stack. Not just a smarter model, a model with memory, a model with tools, a model that understands your company and can actually get work done. Because AI without context guesses. AI with knowledge understands. And AI with access can act.